Beneath the velvet canvas of night, the stars appear eternal. Fixed points of light, shining with a constancy that has guided sailors across oceans, inspired mythologies, and whispered promises of permanence to restless human minds. The constellations are our oldest maps, ancient companions stretching across thousands of years of history, their patterns seemingly immune to the fragility of time. Yet among these eternal flames lies a star that betrays this illusion. Betelgeuse, a colossal red giant burning at the shoulder of Orion. To the eye, it glows with a faint crimson hue, steady and patient, yet inside it trembles with a restless, dying pulse. It is a star swollen beyond comprehension, so vast that if placed where our sun now burns, it would swallow Mercury, Venus, Earth, and even Mars, its surface reaching nearly to the orbit of Jupiter. But its enormity is also its doom. Betelgeuse is unstable, its light flickering like the uneven heartbeat of a fading giant. One night, without warning, it could vanish, collapsing into itself before erupting in a supernova brighter than the full moon. For weeks, perhaps months, the night sky would blaze with an alien light. Orion's shoulder transformed into a beacon that could be seen even in daylight. And then, only darkness, an absence carved into a constellation that has stood unchanged for millennia. Humanity's story has always unfolded beneath Orion, its stars constant, its form unwavering. But what if one of its lights, one of its guides, suddenly disappeared? What if the universe revealed that even the most familiar patterns are fragile, impermanent, waiting to fall apart? The question lingers like a whisper against the silence of the night. Is the universe about to rewrite the sky we thought was eternal? Long before science could name it, Betelgeuse was already etched into human imagination. In the darkness of prehistoric skies, it burned red at the shoulder of Orion, a flickering ember in the heavens. Civilizations gave it names, stories, and meaning. To the ancient Arabs, it was Betelgeuse, the armpit of the giant. To the Greeks, it anchored the hunter's mighty form, a warrior forever chasing prey across the night. For the of New Zealand, it was part of Torturu, a celestial marker for the seasons. Wherever humans looked up, Betelgeuse became a mythic fire, its redness a reminder of both strength and mortality. Yet, even in those earliest myths, something about Betelgeuse was unusual. Unlike most stars, its brightness seemed to shift. Some nights it gleamed with the authority of a ruler among stars. At other times, it seemed to fade, uneasy and restless. Ancient observers could not measure light in numbers, but they felt the star's rhythm, its refusal to remain fixed. It was as though the giant's shoulder breathed with a life of its own. The invention of the telescope transformed this ancient ember into something far more extraordinary. Galileo peered through glass at Orion, yet even he could not unravel its true scale. Betelgeuse still appeared as a single trembling point, defying the limits of early optics. But whispers grew among astronomers. This star was not ordinary. Its glow, its hue, its instability spoke of hidden processes no one yet understood. In the 19th century, as instruments sharpened, the truth began to emerge. Astronomers measured Betelgeuse's angular diameter and discovered it was not just large, but unimaginably vast. If placed at the center of our solar system, its surface would stretch beyond Mars, and in its most expanded phase, nearly to Jupiter. The sun, the giver of life on Earth, would appear as little more than a pinprick swallowed within its volume. Then came the revolution of spectroscopy, the splitting of starlight into its elemental signatures. Betelgeuse's spectrum revealed. Deep crimson lines, the fingerprints of a red supergiant nearing the end of its life. Its hue was not a mere trick of distance, but a warning from physics itself. This was a star burning through its final reserves, a furnace on the edge of collapse. To scientists of the era, the realization was staggering. The sky, once thought eternal and unchanging, was alive with titans whose lives could end in fire. Betelgeuse was no longer just a mythic shoulder of Orion, but a cosmic giant, trembling under the weight of its own fate, a reminder that even the brightest lights can be temporary, even the most colossal beings fragile. When the first true measurements of Betelgeuse were attempted, the results seemed almost impossible to believe. For centuries, the stars had been thought of as distant, tiny, immutable flames. But the data suggested otherwise. Betelgeuse was not small, not ordinary, not even comparable to most of the stars that painted the heavens. It was vast beyond comprehension, a single body of gas and fire so swollen that it defied all expectations of what a star could be. Astronomers, confronted with its scale, struggled to grasp how such a being could exist. A sphere expanding and contracting like a living lung, yet measured in orbits of planets. If Earth's sun is the steady heart of a family, then Betelgeuse appeared as a dying titan, its pulse erratic, its structure stretched thin. The numbers told a story of excess, a star inflated to the very edge of stability, its gravity only barely holding its outer layers together. The debates of the 19th and early 20th centuries reflected both awe and confusion. How could a star so massive and unstable survive for long without tearing itself apart? What stage of life was this? Many believed such giants were anomalies, temporary accidents of nature that defied proper categorization. The science of stellar evolution was still in its infancy, its theories uncertain, its models crude sketches of processes happening in darkness millions of light years away. But as the 20th century unfolded, physics gave shape to the riddle. Nuclear fusion theory, born from the understanding of atoms and energy, began to map the lives of stars. It became clear that Betelgeuse was not an anomaly, but a predictable if extreme outcome of stellar life cycles. It was a red supergiant, a star that had burned through its hydrogen and helium, swelling as heavier elements fused in its core. Its instability was not a mystery of chance, but a law of nature, the inevitable trembling of a giant in its final age. Yet even as theory matured, Betelgeuse continued to defy simplicity. Its brightness rose and fell in patterns that could not be cleanly predicted. It pulsed irregularly, its outer layers convecting with gigantic cells of plasma, each one large enough to engulf Earth entirely. To some, it seemed as though the star itself was breathing, each dimming a long exhalation, each brightening a fleeting gasp for air. In the midst of this, a new discipline was rising, astrophysics, the merging of physical theory with astronomical observation. Betelgeuse became one of its cornerstones. Theories of stellar mass, pressure, energy, and collapse were tested against this star's peculiar rhythms. Each observation was not merely a measurement, but a glimpse into the slow unraveling of a giant. Scientists could not help but imagine it as a colossal being nearing the end of its life, not with calm resignation, but with tremors and convulsions, as if struggling against its fate. The metaphor became inescapable. Betelgeuse was breathing its last, though no one knew when. The final breath would come. It could be tomorrow, it could be 100,000 years. Human lives, civilizations, even entire epochs might pass before that last exhalation of light. And yet, in every tremble, every dimming, the reminder lingered. All things, even the brightest, are finite. The astonishment of Betelgeuse's size did more than challenge the imagination. It unsettled the very foundations of astronomy. For centuries, the stars were regarded as eternal pinpricks, too distant to ever reveal their nature. Now, one of them had become a mirror reflecting the fragility of stellar life. Astronomers realized they were no longer merely charting points of light, but observing living processes on a cosmic scale. Betelgeuse was not a fixed beacon, but a colossal being in motion, swelling and dimming, breathing across centuries. The thought was as humbling as it was terrifying. Even the stars were not immune to death. As the science of nuclear fusion matured in the early 20th century, the narrative of stellar life cycles began to form. A star is born from hydrogen, burns steadily for millions or billions of years, then grows unstable as its fuel dwindles. The sun, small and calm, would one day expand into a red giant before fading into a white dwarf. But stars, like Betelgeuse, lived by different rules. Their mass condemned them to violence. Their lives were short, furious, and unstable, and their deaths would come not as quiet embers, but as detonations that could reshape the galaxy. Betelgeuse, with its swollen body and trembling light, became the archetype of this cosmic truth. Yet, the star's restless behavior remained a puzzle. Its light curve defied neat explanation, brightening and dimming in cycles that overlapped. Sometimes predictable, sometimes chaotic. Astronomers watched and recorded, building archives of numbers that spoke of rhythms but never certainty. Each fluctuation carried the weight of possibility. Was it simply a surface storm, a convective plume larger than the orbit of Earth? Or was it the first tremor of collapse, a whisper of the inevitable implosion that would one day tear its core apart? The mystery gave birth to an emotional intimacy with the star. Scientists, often thought of as detached and clinical, could not help but describe Betelgeuse in metaphors of life and death. In journals and lectures, they spoke of it as if it were breathing, each dimming a long sigh, each brightening a faint resurgence. The language betrayed a truth beyond numbers. They were witnessing mortality on a cosmic scale. The death of a star was no longer an abstract equation, it was a drama unfolding in real time. In the shoulder of Orion, in a light visible to every eye on Earth, this unease fueled the rise of astrophysics as a discipline. The simple act of mapping stars no longer sufficed. To understand Betelgeuse required the merging of physics, chemistry, and celestial observation into a single language. Concepts like nuclear fusion, stellar nucleosynthesis, and hydrostatic equilibrium moved from theory to necessity. BTE demanded answers, and in seeking them, humanity built the tools and models that now underpin all of modern stellar science. It became, in a sense, a teacher. Its convulsions forced astronomers to reckon with impermanence, with complexity, with the limits of their predictions. And yet, the central question remained unanswered. How long could this trembling giant endure before its heart finally collapsed? Theories offered ranges, probabilities, numbers carved into academic papers, but none offered certainty. A century of study brought only deeper ambiguity. Perhaps the end would come in human lifetimes. Perhaps it would not come for 100,000 years. Time, to the star, was vast. To humanity, it was fleeting. And so Betelgeuse remained suspended in a liminal state, neither eternal nor dying, a giant caught between heartbeat and silence, carrying within it the weight of inevitability. The image grew powerful, almost haunting, a titan struggling to breathe, its chest rising and falling in uneven rhythm, while the world below watched in awe and helplessness. The giant's fate could not be stopped, nor hurried, nor even truly understood. Its final breath would come, but no voice could say when. In that silence between expectation and reality, Betelgeuse became more than a star. It became a cosmic reminder of fragility, a red beacon in the night, whispering to humanity that even the grandest fires must one day fall dark. The mystery of Betelgeuse deepened as tools of measurement grew more precise. By the late 19th and early 20th centuries, astronomy was no longer confined to sketching the heavens through glass. The emerging science of photometry, the delicate practice of quantifying starlight, allowed astronomers to capture what the human eye had sensed for centuries. Betelgeuse was not constant. Its brightness swelled and faded with a rhythm both captivating and erratic. To some, it seemed almost alive, breathing in vast cycles that spanned months and years. The first systematic records confirmed what ancient skywatchers had whispered. Betelgeuse flickered with unease, as though its light carried the tremors of its immense and fragile body. This variability revealed something profound about its surface. Unlike the sun, whose face appears uniform and disciplined, Betelgeuse boiled with convective storms so vast they defied comprehension. Astronomers began to imagine a surface broken into colossal cells of rising and sinking plasma, each one large enough to engulf the orbit of Earth. These motions, chaotic and unpredictable, stirred the star's light, causing it to throb and fluctuate in ways no simple model could explain. Betelgeuse was not a steady lamp in the darkness, but a roiling sea of fire, restless even in its apparent stillness. As instruments advanced, new techniques offered glimpses into its true form. Interferometry, the art of combining the light of separate telescopes into a single vision, began to resolve Betelgeuse not as a point, but as a disk. For the first time in history, humanity could see the face of another star beyond the sun. What appeared was astonishing, a sphere imperfect, uneven, mottled with bright and dark regions. Betelgeuse was revealed as a living surface, scarred by eruptions, reshaped by the violence of its own heat. The idea that a star could be directly imaged was revolutionary, and Betelgeuse became the proving ground, its massive form a laboratory for testing the limits of human ingenuity. Yet while science mapped its rhythms, culture embroidered the mystery with its own imagination. The instability of Betelgeuse became fertile ground for speculation and art. Writers saw in its dimming the omen of apocalypse, a herald of celestial collapse. Painters sketched Orion with a wounded shoulder, his crimson fire smoldering toward extinction. In popular science, the possibility of its explosion fueled both fascination and unease. A star that could in a single instant transform the familiar sky into something unrecognizable. Betelgeuse became not only an object of study, but a mirror for human fear and wonder, a reminder that the cosmos, like life itself, held both creation and catastrophe. At the heart of the mystery was its irregular light curve, a pattern that refused prediction. The sun, steady and methodical, embodied stability. Betelgeuse embodied chaos. Its cycles overlapped, collided, and shifted, as though several rhythms were playing at once on an instrument too vast for comprehension. To predict its future was nearly impossible. Theories multiplied, models were tested, but no calculation could pin down when the giant would surrender to its inevitable collapse. The difficulty lay not in ignorance, but in the very nature of massive stars. Unlike the Sun, whose smaller mass ensures long ages of quiet equilibrium, giants like Betelgeuse live precariously, forever near the edge of instability. Their size is both their grandeur and their doom. With every brightening and fading, Betelgeuse revealed a truth written in its core. Stability was only temporary, and the end, though hidden, was certain. The earliest systematic studies of Betelgeuse's shifting brilliance came with the rise of photometry, when light itself was measured with precision rather than mere human impression. The faint pulse that ancient civilizations had sensed with their naked eyes was now captured as numbers, plotted on paper with patient care. Each night's observation revealed something profound. Betelgeuse's glow rose and fell in overlapping cycles, one lasting hundreds of days, another stretching across years. Unlike the steady beat of a pendulum, its rhythm was unstable, colliding waves of brightness and shadow that left astronomers staring at their graphs with both wonder and unease. Here was not the steady heartbeat of a healthy star, but the labored breathing of a giant, vast and fragile, caught in a struggle against its own nature. As these cycles were studied, a picture began to form of what might be happening on Betelgeuse's colossal surface. The Sun, so familiar and ordered, was known to be mottled with sunspots and storms. Yet even its most violent tempests was small compared to what Betelgeuse endured. Models suggested that its outer layers did not merely ripple but convected in cells so vast that each one could swallow the orbit of Earth. These immense currents rose and fell across its crimson face, pushing heat outward in unpredictable waves, then sinking back into the depths of the star's convulsing body. The result was a restless surface, boiling like an ocean of fire, forever reshaping itself in storms beyond comprehension. To study Betelgeuse was to watch a world of flame churning against its own gravity, a being that seemed to breathe in fits and starts, each exhalation measured in light years. The mid-20th century brought a revolution in how this strangeness could be seen. Through the delicate craft of interferometry, combining the light of multiple telescopes into a single, sharpened vision, astronomers finally resolved Betelgeuse as more than a distant point. What emerged was astonishing. The star's disk, enormous in the sky despite its distance, appeared scarred and uneven, mottled with bright patches and darker shadows. It was the first time humanity had gazed upon the face of a star other than the Sun, and the image was startling in its imperfection. Betelgeuse was not the smooth, symmetrical sphere that textbooks suggested, but a turbulent giant wounded by eruptions and storms. In its shimmering surface, science glimpsed not a static object, but a living entity, its light bearing the signature of a body in turmoil beyond observatories. Betelgeuse's reputation spilled into the wider imagination, in literature and art. It became a star of omen, its crimson hue a symbol of mortality and transformation. The instability of its glow inspired tales of collapse, cosmic rebirth, and worlds watching their sky dissolve. Popular science journals speculated on its eventual supernova, sometimes with sober curiosity, sometimes with apocalyptic fervor. To the public, Betelgeuse was no longer just another star in Orion, it was a ticking clock, a mystery with the power to redraw the heavens overnight. Its variability blurred the line between scientific data and mythic dread, reminding humanity that even the sky, once a symbol of permanence, was fragile. At the core of this fascination lay a problem that still haunts astronomy: prediction. The sun, modest and steady, offers cycles that can be charted and trusted. Betelgeuse resists. Its overlapping rhythms, its chaotic storms, and its swollen, unstable layers make it nearly impossible to forecast its next act. Will its next great dimming be the herald of collapse, or simply another breath in its centuries-long struggle? The light curve that astronomers so carefully traced became not only a graph of numbers, but a symbol of uncertainty itself, the restless heartbeat of a star whose fate is inevitable, yet whose timing remains hidden behind the veil of cosmic silence. In these early investigations, Betelgeuse revealed itself as both subject and teacher. It forced astronomy to expand its tools, to refine its instruments, to peer deeper into the mysteries of stellar life and death. But it also forced something more unsettling: the acceptance that even with all the science, all the mathematics, the final moment of a star's death cannot be neatly predicted. Betelgeuse lives on borrowed time, but its hourglass is hidden. Humanity watches, records, and waits, knowing that one day its fire will falter, yet never knowing if that day lies tomorrow, or far beyond the span of human history. For centuries, Betelgeuse had been a subject of speculation, but in the modern age of space telescopes and precision instruments, it began to reveal its secrets in ways no one could have imagined. High above Earth, the Hubble Space Telescope turned its golden mirrors toward the swollen giant and witnessed something extraordinary: vast plumes of gas erupting from its surface, spilling into the void like smoke from a cosmic volcano. These eruptions were not gentle exhalations, but titanic explosions, each greater than the mass of entire planets, hurled outward by the convulsions of a dying star. They drifted into space, cooling, condensing, and carrying with them the fragile memory of a body struggling to hold itself together. Hubble's vision confirmed what theory had long suspected: Betelgeuse was shedding its outer layers, bleeding into the darkness, preparing for an end that seemed to draw closer with every observation. Then came the winter of 2019. Night by night, Betelgeuse began to fade. Amateur astronomers were the first to notice it, their backyard telescopes recording a crimson glow that dimmed with unusual haste. Soon, professional observatories confirmed the strange decline, and the world's attention was fixed upon Orion. By early 2020, Betelgeuse had lost more than two-thirds of its brilliance, its once dominant beacon reduced to a pale ember. The news spread like wildfire. Was this the final warning? The moment the star would at last collapse and explode as a supernova? Headlines erupted across the globe. The end of Betelgeuse, a supernova in our lifetime. For the first time in generations, a star became a character in the human story, its fate debated on front pages and television screens. The sky itself had become breaking news. At the European Southern Observatory, the very large telescope stared into the fading giant with its unparalleled vision. The images it captured astonished astronomers. The dimming was not the extent of a core, but the shadow of a veil. A colossal dust cloud, born from Betelgeuse's own ejected gases, had drifted across our line of sight, shrouding the star in cosmic smoke. It was as if the giant had drawn a curtain across its face, hiding its true brilliance behind a mask of its own making. The great dimming, once thought to herald the star's death, was revealed instead as an episode of self-obscuration. Dramatic, yes, but not terminal. The collapse was postponed, the finale delayed, yet the scientific explanation did not quiet the deeper resonance of the event. Humanity had glimpsed, however briefly, the fragile mortality of a star that has burned for millions of years. The tension between what science explained and what imagination feared left a haunting impression. The star was not about to explode, and yet the fact remains, it will explode. Whether tomorrow or in 100,000 years, Betelgeuse is fated for a violent death, its core destined to collapse and ignite a supernova brighter than any in recorded history. The Great Dimming had been only a rehearsal, a cosmic whisper of what will one day come. In that brief season of uncertainty, the gap between cosmic timescales and human longing became painfully clear. Astronomers knew that the odds of witnessing Betelgeuse's final blaze in a human lifetime were vanishingly small, but the public hoped otherwise. We yearn for spectacle, for signs in the heavens that remind us of our place in the story of the universe. Betelgeuse had offered just enough to awaken that yearning, only to recede again into patient silence. In the aftermath, the star remained unchanged, but humanity was altered. For a fleeting moment, the cosmos felt alive and immediate, a stage where endings might unfold before our very eyes. And though the dust has long since cleared, the memory of Betelgeuse's dimming lingers, a reminder that even the brightest of lights can falter, and that somewhere in the silence of the universe, the clock of a giant is still ticking toward its final hour. The Great Dimming was not simply a fleeting astronomical curiosity. It was a test of modern science, a reminder that even with the finest instruments humanity has ever built, the cosmos still has the power to surprise. Teams of astronomers across the world scrambled to collect data. Spectrographs measured the wavelengths of Betelgeuse's fading light, searching for the chemical fingerprints of what might be happening in its atmosphere. Photometers tracked every flicker, every tiny change, turning the star's pulse into a coded language that scientists tried to decipher. Some models suggested internal disturbances, giant convective cells rising from deep within the stellar interior, altering the energy flow from core to surface. Others pointed outward, toward the clouds of matter that Betelgeuse was known to expel, which might have thickened and cooled just enough to block its light from Earth's view. In the face of fading brilliance, the interpretations multiplied, each carrying its own implications for the fate of the giant. The sheer scale of the star's surface was itself a puzzle. Betelgeuse is so vast that if it were placed at the center of our solar system, its outer layers would engulf the orbit of Jupiter. On such a canvas, the boiling convective cells, immense bubbles of plasma rising and falling, are not the size of continents, as on Earth, but the size of planets. Each surge and collapse ripples across the stellar atmosphere, disturbing the fragile equilibrium that holds the giant together. The 2019 dimming, when viewed through this lens, became more than a passing shadow. It was an illustration of instability, on a scale almost impossible to grasp. Astronomers described it as watching a star breathe in uneven rhythms, exhaling in bursts of dust and gas that momentarily dimmed its light, then inhaling again as the debris drifted away into the void. Made the moment so gripping was the way it collapsed the distance between human imagination and astrophysical reality. For centuries, the death of stars had been the domain of theory and myth. The ancients looked at Orion and wove tales of hunters and heroes, never suspecting that one of its brightest jewels would someday end in fire. But when the Great Dimming reached the headlines, millions of people turned their gaze skyward, seeing not a myth but a question. Could this be the day the heavens changed forever? The possibility of a supernova in our lifetime electrified the public. Articles speculated about how bright it might appear, as luminous as the full moon. Some claimed, casting shadows in the night, and visible even under the midday sun. The sober voice of science reminded the world that the odds were slim. Yet the thought lingered. One day it will happen. For researchers, the dimming became a laboratory of the sky. Every telescope that could turn toward Orion was enlisted. NASA's Solar and Terrestrial Relations Observatory measured the ultraviolet signatures of the star's outflows. Infrared telescopes captured the glow of dust as it spread outward, cooling into delicate grains that veiled the star's brilliance. Computer models of radiative transfer traced how light interacted with the dust, simulating the ways a star might hide itself behind its own breath. Bit by bit, a picture emerged. Betelgeuse had likely experienced a massive surface eruption, a convective plume so large it destabilized a portion of the star's outer layers. That ejected matter then cooled rapidly, forming a dust cloud dense enough to block visible light. From Earth's perspective, the Great Dimming, far from a herald of collapse, was the signature of a star in the throes of violent but survivable outbursts, the kind that marked the turbulent twilight of stellar life. Yet science did not erase the deeper wonder. Even when the equations were written, when the dust was modeled and the timelines revised, the event retained its symbolic power. It reminded humanity of how fragile perception is. A star more than 500 light-years away had exhaled, and that breath had traveled across space to touch our world. For months, the collective gaze of humankind was fixed on a single point of light in Orion, waiting for it to flicker, waiting for it to bloom, waiting for a signal that the universe had shifted. The fact that it did not explode did not diminish the story. Instead, it drew a sharper contrast between human impatience and cosmic scale. To us, months of dimming felt urgent, apocalyptic. To a star, it was no more than a sigh. Even now, the legacy of the Great Dimming continues to ripple through astronomy. Betelgeuse became not only a scientific case study, but a reminder of humility. The star remains alive, still swelling and contracting, still shedding matter into space, still whispering of an ending yet to come. Its fate is written in physics. Eventually, its core will collapse, and its outer layers will be cast into the galaxy in one of the most luminous explosions nature can provide. But eventually is the language of stars, not of humans. For us, the uncertainty remains part of the awe. Betelgeuse could endure for another 100,000 years, or its final blaze could have already begun, with the light of its death racing toward us, unseen, arriving tomorrow, or the next year, or the next century. And so the story of Betelgeuse lingers in tension, not because the science has failed, but because the cosmos does not conform to human timescales. The Great Dimming was not the end, but a rehearsal, a glimpse of how fragile even the brightest lights can appear. For astronomers, it became proof of the power of observation, the triumph of instruments like Hubble and the Very Large Telescope. For the rest of humanity, it became a meditation on mortality written across the sky. Even the giants fall, but they fall in their own time, not ours. And while the curtain has lifted, and Betelgeuse shines again with steady brilliance, the memory of its fading remains a haunting echo of a future yet to come. A reminder that somewhere in Orion, a clock is ticking toward a fire that will someday outshine every star in the heavens. As observations of Betelgeuse deepened, the star revealed behaviors that challenged every expectation. The violent ejections of gas and dust seen during the Great Dimming were only the beginning. Subsequent measurements indicated that Betelgeuse was shedding mass at rates far beyond what models had predicted for red supergiants. Vast clouds of plasma, each heavier than entire planets, were being hurled into space, driven by convective motions and shocks from deep within the star. These eruptions were not random flickers, they were colossal outbursts, chaotic yet patterned, as though the star's body was both resisting and surrendering to the inevitable laws of physics. Each ejection was a reminder that Betelgeuse was not merely a textbook example of a dying giant, but a living, unpredictable entity whose behavior pushed the limits of stellar theory. Even more perplexing was the asymmetry of the star's surface. Early models had assumed that red supergiants were roughly spherical, their enormous volumes evenly distributed around a central core. But interferometry and high-resolution imaging revealed a surface broken by giant convective cells, enormous, bright and dark patches, and protrusions of plasma rising far above the average stellar radius. The star was distorted, irregular, almost misshapen, a far cry from the smooth spheres depicted in scientific diagrams. These asymmetries suggested that Betelgeuse was not merely unstable, but fundamentally chaotic in ways that current physics could describe only partially. It was a star that defied symmetry, a cosmic giant whose face seemed to shift like a living creature, hinting at interior processes both vast and violent. Compounding the mystery were the discoveries of magnetic fields threading through the star's outer layers. Observations suggested turbulence on scales unprecedented for a red supergiant, hinting at plasma flows and convective motions far more complex than previously imagined. Magnetic loops twisted and tangled across the surface, interacting with ejected matter, shaping dust clouds, and perhaps influencing the timing and intensity of outbursts. The star's atmosphere, once thought placid compared to the core, was revealed as a cauldron of energy and motion, a maelstrom governed by forces that only the most advanced computational models could attempt to simulate. Betelgeuse was a laboratory of extremes, a star whose dynamics seemed almost alien, a reminder that nature does not adhere strictly to expectation. The deeper astronomers looked, the less predictable Betelgeuse became. The problem was not merely scale or distance, it was fundamental uncertainty. While nuclear physics dictates that a star of this mass will ultimately collapse, the precise timing remains impossible to define. It could explode tomorrow or survive another 100,000 years. The interior is hidden beneath thousands of kilometers of incandescent plasma, and the mechanisms that trigger a supernova, core density thresholds, fusion, exhaustion, shock, propagation, are inaccessible to direct observation. It is as if humanity has seen a lightning bolt form in the sky, yet stands uncertain of when the thunder will strike. The tension is philosophical as much as scientific, an event written in inevitability, but rendered unpredictable by the vastness of time and scale. Betelgeuse had become more than a star, it was a cosmic enigma. Its violent outbursts, irregular shape, and hidden magnetic turmoil suggested it was not merely behaving differently than expected, but perhaps operating in ways that no star previously studied had ever shown. Each observation added layers of complexity. Each model introduced new uncertainties. Scientists began to ask questions they could not yet answer. Was Betelgeuse truly unique? Or had humanity simply lacked the instruments to see similar behavior in other giants? The waiting, the uncertainty, and the fragile awareness of a star's mortality became central to the human fascination. The giant's heartbeat continued, irregular and unyielding, and the universe held its secret. We watch, we calculate, we speculate, yet the thunder, the supernova, remains distant, its timing a mystery. echoing across a cosmic expanse where even the most brilliant lights are transient, and the most colossal beings, impermanent. As astronomers probed further into Betelgeuse's behavior, it became clear that the star's outbursts were not isolated incidents, but part of a larger, more complex pattern of instability. Data from space-based telescopes and ground observatories revealed that the star's outer layers were constantly in motion, sloshing and convecting in ways that challenged classical models of stellar equilibrium. Gigantic bubbles of plasma, tens to hundreds of times the size of Earth, rose from the star's interior, only to collapse and surge again, stirring turbulence that propagated across its surface. These motions were amplified by the star's rotation, however slow, and by the immense gravitational forces pressing inward. The interplay of these forces produced eruptions that could hurl mass into space with energies comparable to millions of nuclear bombs. Each event was a reminder that Betelgeuse was not merely a passive giant waiting to die, but an active, volatile force, a star whose surface and atmosphere were alive with motion on scales almost impossible to imagine. The asymmetry of Betelgeuse's surface became an enduring puzzle. Observations showed that brightness and temperature varied dramatically across its face, with some regions glowing intensely while others appeared darker, almost cratered. The traditional image of a smooth, spherical supergiant gave way to a far more chaotic reality, a stellar landscape of peaks and valleys, of luminous ridges and shadowed depressions, all in motion. These variations suggested that energy transport within the star was far from uniform, and that conventional models of hydrostatic equilibrium could only approximate its true behavior. For the first time, astronomers were forced to consider that Betelgeuse might not behave like any red supergiant previously studied. Its internal processes, from fusion in the core to the convective surges in the outer layers, seemed to operate in a delicate, precarious balance, one whose disruption could trigger an event both catastrophic and sudden. Adding to the enigma were the magnetic fields detected across Betelgeuse's atmosphere. These fields, twisted and tangled by the roiling plasma beneath, appeared to influence the ejection of material and the formation of dust clouds, creating patterns of turbulence that were both visible and invisible. Magnetic loops, spanning millions of kilometers, interacted with charged particles in ways that amplified instabilities on the surface. It was a portrait of chaos shaped by physics, a star governed by gravity and fusion, yet sculpted by magnetism, and turbulence on scales that human instruments were only beginning to resolve. Each new measurement revealed deeper layers of complexity, hinting that Betelgeuse's eventual fate could unfold differently than any standard prediction. Its path to supernova influenced by forces both seen and hidden. And yet, despite the growing wealth of observations, the timing of Betelgeuse's death remained an insoluble riddle. Models of stellar evolution predicted collapse, but they could not pinpoint when. The core could continue to fuse heavier elements for decades, centuries, or millennia, while the outer layers swelled and contracted, occasionally erupting in violent spasms of mass loss. To astronomers, it was like watching a lightning bolt form in slow motion, knowing that thunder would follow, yet unable to say when it would strike. The gap between human perception and cosmic time had never felt so acute. The great dimming of 2019 had been a rehearsal, a dramatic episode, but the true climax remained beyond reach. A reminder that in the universe, inevitability does not coincide with immediacy. Betelgeuse had become a living paradox, enormous yet fragile, luminous yet transient, a giant whose behavior confounded models and exceeded imagination. Its violent eruptions, distorted surface, and tangled magnetic fields challenged the assumptions of stellar astrophysics, forcing scientists to revise long-held theories and embrace uncertainty. In contemplating the star, humanity glimpsed the limits of prediction and the scale of cosmic time. To wait for Betelgeuse's final explosion is to wait on a scale alien to human life, a meditation in patience and humility. Each pulse of light, each shift in brightness, each dust cloud drifting across its face is a whisper from the universe that even the greatest flames are finite, and that the cosmos, in all its beauty, is governed as much by unpredictability as by law. The giant's heartbeat continues, hidden yet perceptible through the telescopes that probe its light. Every surge of plasma, every outflow of gas, every subtle change in surface intensity is a note in a composition that spans millennia. Humanity can observe, measure, and theorize, yet cannot hasten or delay the inevitable. In this uncertainty lies both the terror and the awe of Betelgeuse, a star alive with mystery, a titan breathing in rhythms that defy comprehension, and a cosmic reminder that the universe is vast, indifferent, and endlessly surprising at the extreme edge of science. Betelgeuse becomes more than a subject of observation, it becomes a threshold between comprehension and awe. The physics of its eventual death are among the most violent and energetic events in the universe. When a star like Betelgeuse exhausts the nuclear fuel in its core, it leaves behind an iron core that can no longer support its own weight. In an instant, measured in seconds, gravity overwhelms the core, triggering a catastrophic collapse. The imploding material rebounds violently, sending shockwaves through the outer layers and producing an explosion of such intensity that it can outshine entire galaxies for brief moments. The energy released is almost incomprehensible. A single supernova emits as much energy as the Sun will in its entire 10 billion year lifetime. To witness such a transformation in a nearby star would be to watch the fundamental power of nature writ large across the heavens. For observers on Earth, the spectacle would be surreal. Calculations suggest that when Betelgeuse detonates, it could appear as bright or brighter than the full moon, bathing the night sky in a crimson-white brilliance for weeks. Shadows would lengthen. Colors of the natural world would be subtly altered by its glow, and a familiar constellation, Orion, would suddenly bear the unmistakable mark of death. Unlike distant supernova that are mere points of light, Betelgeuse's explosion would dominate the sky, a drama unfolding in real time, visible to anyone who lifts their eyes after dark. It is a cosmic performance for which no human civilization has ever been prepared, a reminder that the heavens are not immutable but dynamic, capable of producing awe that transcends both time and imagination. Before the brilliant light reaches us, the universe may deliver subtler signals. Neutrinos, ghostly particles that escape from the heart of the collapsing core, would surge outward at nearly the speed of light, arriving hours or even days before the visible explosion. Their passage would offer the earliest whisper of the star's final breath, detectable only by the most sensitive instruments, a prescient message from the cosmos itself. Gravitational waves, ripples in the very fabric of space-time predicted by Einstein and first directly observed in 2015, might accompany the collapse emanating from Betelgeuse as it contorts and rebounds in the final instant of equilibrium lost. Though undetectable to the senses, These waves carry the signature of violent motion across light years, a silent echo of a colossal upheaval. Despite the overwhelming energy of the explosion, Earth itself would remain unharmed. The star is distant, enough that the destructive effects of radiation or shock would not reach the planet, yet the intellectual and emotional impact would be profound. Witnessing such an event would be unprecedented. A human eye perceiving the death of a star, a civilization marking a singular moment in the history of the cosmos. Philosophically, it would confront humanity with its own smallness, with the immensity of time and energy in which our brief lives are embedded. It is a lesson in patience and perspective. We live under skies that are active, tumultuous, and indifferent, where creation and destruction play out on scales both vast and intimate. To imagine Betelgeuse's end is to imagine a bridge between theory and experience. The supernova embodies physical laws pushed to their limit, a chain reaction that begins in the dense iron core and culminates in a display that transcends imagination. It is both a natural inevitability and a cosmic spectacle, a demonstration of power and fragility entwined. While humanity waits for decades, centuries, or millennia, the star pulses with quiet energy. Each eruption, each shift, a reminder that the end approaches in a language written in light, matter, and gravity. In this extreme, science becomes poetry. The collapse of a star is not merely an equation, but an event capable of inspiring awe, humility, and reflection in those who dare to watch. Betelgeuse, in its final act, will offer a rare convergence of observation and theory, a fleeting moment when human understanding meets cosmic drama. The potential supernova is not just a scientific event, it is a narrative of scale and inevitability, a lesson written in the language of the universe. It confronts humanity with the simultaneity of knowledge and mystery, showing that the extremes of physics can also be the extremes of imagination. The anticipation, the speculation, the instruments poised to record its death. All of it reminds us that the universe is not static, that even the most familiar points of light are subject to transformation, and that the edge of science is where awe and inquiry meet, waiting patiently in the shoulder of Orion for a finale no eyes have yet beheld. Even as astronomers chart the inevitability of Betelgeuse's collapse, the star remains an enigma in the details. Supernova models describe the stages in broad strokes: core collapse, shockwave propagation, and the violent expulsion of the outer envelope. Yet Betelgeuse's peculiarities, its enormous convective cells, asymmetrical surface, and tangled magnetic fields introduce uncertainties that defy precise prediction. Will its final collapse proceed in a smooth, spherical fashion, or will the irregularities of its structure sculpt an explosion of unexpected geometry? Simulations suggest that the distribution of mass and magnetic energy could create plumes and jets, producing a supernova that is more sculpture than simple flash. To imagine it is to envision a firestorm in space, sculpted not by human intention, but by the chaotic balance of forces within a dying giant. Each variable, each instability, transforms the expected event into a masterpiece of cosmic unpredictability. Neutrinos, escaping unimpeded from the collapsing core, offer humanity a whisper of the imminent catastrophe long before visible light reaches Earth. In laboratories buried deep beneath mountains, massive tanks filled with water or other target material are poised to capture these elusive particles, their interactions recorded as faint flashes in otherwise dark chambers. The arrival of a neutrino burst would be the first signal that Betelgeuse's core has faltered. that the star has begun the final transformation from burning giant to supernova remnant. Gravitational wave observatories, tuned to detect ripples in space-time, may record the convulsions of the core as it collapses, transmitting an echo of the cataclysm across light years. These silent messages, invisible to the senses, would announce an event unparalleled in human experience, the death of a star in real time, before its brilliant light has yet reached our eyes. On Earth, the spectacle of the supernova would be at once beautiful and humbling. Betelgeuse would dominate the night sky, a point of crimson-white light far brighter than Venus or even the full moon. Shadows would stretch across landscapes under its glow, familiar objects bathed in alien luminosity. For weeks, its brilliance would persist, slowly fading as the energy radiates outward, leaving behind a nebula of expelled matter, a fingerprint of the star's final act. Despite the grandeur of this cosmic display, humanity would remain physically unharmed. The distance, though vast in terms of light years, is sufficient to shield Earth from lethal radiation or shockwaves. Yet the psychological impact, the confrontation with the immediate visibility of stellar death, would be profound. Civilizations have never witnessed such an event in real time, and to see it unfold in a constellation so familiar would be an experience both exhilarating and unsettling, a direct encounter with the scale and inevitability of cosmic processes. The philosophical resonance is as compelling as the physical spectacle. Witnessing the death of a star with human eyes challenges our perception of permanence. For millennia, Betelgeuse has served as a guidepost, a constant in the night sky, marking seasons, inspiring myths, and shaping human navigation and imagination. Its sudden demise, brilliant and overwhelming, would rewrite the familiar heavens, a reminder that the universe is not static, that the celestial tapestry is alive with creation and destruction. In observing its final act, humanity confronts both its own brevity and the persistence of natural law, where time stretches and compresses in ways alien to daily experience. Betelgeuse's life and death become a mirror, reflecting the tension between inevitability and unpredictability, between comprehension and wonder. Even in anticipation, the supernova forces a meditation on the scales of existence. Scientists prepare with instruments and simulations, yet no algorithm can fully capture the visual, emotional, or philosophical magnitude of the event. The extremes of physics, gravitational collapse, nuclear fusion runaway, and plasma ejection meet the extremes of human curiosity, producing a spectacle that transcends empirical study. Betelgeuse, poised on the brink, embodies the ultimate convergence of observation and imagination, of measurement and awe. It stands as a testament to the power and fragility of stars, a cosmic monument to forces beyond comprehension, yet intimately linked to the human urge to witness, to understand, and to marvel. The star's pulse continues, each convective surge and gas ejection a reminder that death in the cosmos is a process, not a single instant. Betelgeuse teaches patience, humility, and the art of waiting on a scale beyond the human lifespan. And yet, in the very act of waiting, the mind can imagine the grandeur. The light flooding the sky, the shadow of dust, the neutrino whispers racing through the universe, and the silent, powerful ripples through space-time. In that anticipation, science becomes poetry, and the edges of knowledge are defined not just by what is known, but by the awe inspired by what is possible. The death of a star, when it finally comes, will be both an answer and a question, a revelation of nature's might and a meditation on humanity's place beneath the eternal sky. Mainstream science views Betelgeuse through the lens of accumulated knowledge, a discipline refined over centuries of observation and theory. Astronomers agree that the star is in its late red supergiant phase, a stage of stellar evolution characterized by exhaustion of core hydrogen and helium, swelling of the outer envelope, and instability in the outer layers. In this stage, stars of Betelgeuse's mass, roughly 20 times that of the Sun, expand to enormous proportions, their surfaces roiling with convection and turbulence, their luminosity varying in subtle but detectable ways. The irregular pulsations that have captured both public and scientific attention are understood as natural consequences of these processes. Convection cycles that bring hot plasma from the interior to the surface, alternating with cooler material, sinking inward, combined with the oscillating pressure of radiation escaping the star. These pulsations are a heartbeat, steady and measurable, a signature of a star still alive, though nearing the end of its life. Within the frameworks of stellar evolution, models predict that Betelgeuse's ultimate collapse is inevitable, but the timing is uncertain. Estimates generally place it within the next 100,000 years, a span that dwarfs human history and perspective. This window, though narrow in cosmic terms, allows the star to continue its episodic shedding of matter, producing clouds of dust and gas that momentarily obscure its light and create phenomena like the Great Dimming of 2019. Dust formation in this context is neither anomalous nor unexpected. It is an intrinsic feature of massive stars losing their outer layers in pulses, winds, and eruptions. The mass expelled eventually enriches the interstellar medium, seeding future generations of stars and planets, a reminder that even the death of a star is an act of creation on a grand scale. Comparisons with other red supergiants reinforce this framework. Stars such as Antares, in Scorpius, or the progenitor of SN 1987A have displayed similar behaviors: pulsations, irregular surface structures, episodic mass loss that match predictions from hydrostatic and hydrodynamic models. These parallels allow astronomers to contextualize Betelgeuse not as a cosmic anomaly, but as a natural exemplar of massive stellar evolution. Observations of these counterparts, alongside theoretical modeling, provide a template for understanding the life cycle of supergiants, a delicate balance between core fusion, envelope instability, and energy transport, all governed by well-established physics. Mainstream science, however, cautions against sensationalism. Headlines about an imminent supernova often misrepresent the timescales involved, suggesting urgency where none exists. While Betelgeuse may indeed explode one day in a brilliant supernova, the odds of witnessing this event in a human lifetime remain vanishingly small. Scientists emphasize patience and careful observation, focusing on measurable phenomena rather than speculation. This approach does not diminish the drama of the star or the beauty of its light, but situates human curiosity within the proper scale of cosmic events, balancing awe with rigorous understanding. In this light, Betelgeuse is both extraordinary and familiar, a giant nearing the end of its life, pulsating and shedding, yet behaving according to the principles that govern stars throughout the universe. Its surface may flare, its brightness may fluctuate, and dust may veil its face. But these behaviors fit into a coherent narrative, the natural progression of a massive star toward eventual collapse. The mainstream view frames Betelgeuse not as an unpredictable harbinger of sudden catastrophe, but as a predictable actor in the slow, grand theater of stellar evolution, where mass, energy, and time converge to shape the fate of the universe. The star's story is written in physics, yet it continues to inspire wonder, reminding humanity that understanding and awe are not mutually exclusive, but complementary ways of experiencing the cosmos. Beyond the rigor of mainstream astrophysics lies a terrain of speculation, a place where observations hint at possibilities that challenge conventional understanding. Among these is the unsettling notion that Betelgeuse may collapse far sooner than standard models predict. While mainstream theory situates its final supernova within tens of thousands of years, some analyses of surface instabilities, convective surges, and sudden ejections suggest that the star could be closer to the end of its life than previously imagined. These hypotheses are fueled by the irregularities in its brightness, the asymmetry of its surface, and the turbulent magnetic fields threading its atmosphere. Could such anomalies indicate a hidden acceleration in its evolutionary clock, a precursory tremor of an event humanity cannot yet measure? The question hangs like a shadow across the night sky, the certainty of inevitability, tempered by the profound unknowability of timing. Speculation also extends to Betelgeuse's possible interactions with an unseen companion. Some models suggest that a binary partner, perhaps a compact object or a faint star, could subtly influence the red supergiant's behavior. Gravitational tides might induce localized surges or trigger surface instabilities, enhancing mass loss in irregular bursts. If such a companion exists, it may have remained undetected, concealed by the luminosity and chaotic surface of Betelgeuse itself. The idea stretches the imagination, but it remains anchored in physics. Stars in binary systems often experience mutual perturbations, and these interactions can have dramatic consequences over astronomical timescales. More exotic and unsettling is the hypothesis that Betelgeuse may have already partially collapsed internally, hidden beneath the layers of plasma that mask its deepest workings. If the core has begun to compact prematurely, sending subtle signals that are difficult to detect from Earth, the star may be quietly advancing toward catastrophe. Such a scenario would challenge the very methods by which astrophysicists measure stellar evolution, highlighting the limits of observation, the assumptions embedded in models, and the possibility that nature operates in ways beyond current comprehension. Fringe theories, while speculative, emphasize the humility inherent in science, the recognition that certainty is provisional, and that even well-studied stars can harbor secrets at the edge of understanding. Betelgeuse becomes a mirror for philosophical reflection. How much of science is projection, an effort to impose order upon patterns that are only partially visible? How much is genuine insight into the workings of the cosmos? The star's behavior reminds humanity that knowledge is always provisional, that the universe retains mysteries no telescope can fully resolve. In this context, Betelgeuse is a ticking clock with no hands, a presence whose final chime may echo across space without warning. Observers can track pulses, dust clouds, and magnetic shifts, but the ultimate signal, the supernova itself, remains uncertain. Yet it is precisely this uncertainty that magnifies the star's power to inspire. Every unexplained flicker, every asymmetrical bulge, every anomaly in its ejected material becomes a prompt for imagination, a canvas for thought experiments that test the limits of physics and philosophy alike. Betelgeuse straddles the boundary between known law and potential anomaly, inviting questions about the reliability of human models in the face of cosmic scale. To contemplate it is to acknowledge both the genius and the humility of science, to measure, to predict, and ultimately to stand in awe, before a force that transcends prediction. Even speculation, in this case, is a form of reverence, a recognition that the universe is richer, stranger, and more unpredictable than the sum of our equations. Betelgeuse, in its speculative forms, teaches patience as well as wonder. It embodies the tension between certainty and mystery, between observation and imagination. In every theory, whether mainstream or fringe, the star pulses with the same unresolved question: when will the inevitable collapse occur? And what will it reveal about the forces shaping the cosmos? Humanity can listen to its subtle signals, model its behavior, and speculate with the best tools and intellect available, yet the final act remains unknowable. It is a meditation on scale and mortality, a lesson written across the heavens, that even the brightest, largest, and most studied stars can keep their deepest truths hidden, whispering only in light, dust, and magnetic stirrings until the day they decide to reveal themselves fully. Speculative models also explore the possibility that Betelgeuse's interior may be more advanced in its evolution than surface observations alone suggest. Neutrino emissions, subtle shifts in its oscillation patterns, and anomalies in the velocity of ejected material have led some theorists to propose that the core may already be partially collapsed, quietly accumulating iron and heavier elements in preparation for the inevitable supernova. If true, this would mean that the violent death of the star is not merely a distant future event, but a process already underway, hidden beneath thousands of kilometers of incandescent plasma. The idea is as unsettling as it is fascinating. A star that appears alive to the naked eye, yet is silently preparing for a transformation that will reverberate across the cosmos. It is a reminder that appearances in astronomy can be deceptive, that the external brilliance of a star may mask profound internal changes, imperceptible until the final moment. Some fringe theories even entertain the notion that Betelgeuse may be a natural laboratory for physics beyond current models. Could its extreme mass, turbulent convection, and irregular outbursts be hinting at exotic phenomena, such as non-standard neutrino interactions or magnetic instabilities on unprecedented scales? While these ideas remain speculative, they are grounded in real science. Our understanding of high-mass stellar evolution, magnetic field amplification, and plasma dynamics is incomplete. Betelgeuse, in this view, is not just a dying star, but a challenge to the boundaries of knowledge, a reminder that the universe may harbor behaviors and forces that stretch beyond human imagination, waiting to be discovered by those with patience and vision. The philosophical resonance of these speculations is profound. They force a confrontation with the limits of human understanding, highlighting the delicate balance between prediction and humility. Every model, every simulation is only as reliable as the assumptions it is built upon, and Betelgeuse continually exposes the cracks in these assumptions. The stars, pulsations, dust clouds, and magnetic anomalies serve as echoes of cosmic truths that humans can glimpse but never fully grasp. In this sense, Betelgeuse becomes a mirror for scientific thought itself, a symbol of both our capability to observe and theorize, and our inherent inability to predict nature's most profound acts with absolute certainty. It is a ticking clock with no hands, whose echoes we hear in pulses of light and matter, yet whose final chime remains unknowable. Even in the realm of speculation, Betelgeuse inspires awe and reflection. The possibility that it could collapse sooner than anticipated, or harbor hidden processes invisible to our instruments, transforms the star from a distant object of study into an intimate philosophical presence. It embodies the tension between certainty and uncertainty, between what we know and what we can only infer. Every eruption, every asymmetry, every irregular dimming becomes a narrative thread in a story whose ending is yet unwritten. In contemplating these fringe possibilities, humanity is invited to embrace the mystery, to accept that the universe is not merely a collection of data points, but a vast, dynamic system whose scale and complexity exceed the reach of any single mind. At the speculative edge of science is both a warning and an inspiration. It teaches that even with the most sophisticated instruments, the most detailed simulations, and the most rigorous theories, the universe retains secrets beyond our grasp. It pulses with the reminder that science is a dialogue with the unknown, that curiosity and humility must coexist, and that wonder is as essential to understanding as measurement. In the interplay between observation and speculation, between fact and possibility, Betelgeuse stands as a sentinel, a cosmic giant whose life and death force humanity to confront the profound scales of time, energy, and inevitability, and to listen carefully for the echoes of a final chime that may arrive without warning. Across the globe, telescopes and observatories maintain a vigilant watch on Betelgeuse, as if holding a finger to the pulse of a sleeping giant. Ground-based interferometers, combining light from multiple telescopes, resolve details of its vast, roiling surface, revealing the shifting convection cells and subtle asymmetries that hint at internal processes beyond direct observation. Space-based observatories, free from atmospheric distortion, capture ultraviolet and infrared emissions, charting the ejection of gas and dust in exquisite detail. Each observation contributes to a tapestry of understanding, a multidimensional portrait of a star on the threshold of cosmic change. The instruments themselves are monuments to human ingenuity, designed to catch subtle variations that occur over days, weeks, and decades. A patient vigil in service of knowledge. Beneath the surface of light, hidden signals await discovery. Neutrino detectors, such as Super Kamiokande in Japan and IceCube at the South Pole, stand ready to intercept the nearly massless particles that escape unimpeded from the star's core. Should Betelgeuse's core begin its final collapse, these ghostly messengers would arrive long before photons, providing an early warning of the supernova to come. Scientists monitor these detectors continuously, interpreting faint flashes in tanks of water or ice as whispers from the dying star. It is a form of cosmic listening, a practice of anticipation and attention that stretches human perception to its limits, transforming invisible particles into a narrative of impending transformation. The advent of next-generation observatories promises an even deeper gaze. The James Webb Space Telescope, with its unprecedented infrared sensitivity, can probe the cooler outer layers of Betelgeuse and the dust clouds surrounding it, revealing patterns of mass loss and surface temperature variations with extraordinary clarity. Coupled with advances in adaptive optics on Earth, astronomers are approaching the capacity to map the star's surface almost in real time, turning theoretical models into observational fact. Yet even as these technologies push boundaries, they illuminate the vastness of cosmic timescales. The star's ultimate fate may unfold over centuries, decades, or mere days, and science must balance patience with readiness. Global networks of astronomers coordinate their efforts with remarkable precision, sharing data in real time and maintaining a collective vigilance. From professional observatories to citizen science initiatives, the community is poised to record every nuance should the supernova begin. This coordination reflects both the collaborative spirit of modern science and the recognition that some events are too monumental to be observed in isolation. Yet these efforts also face practical constraints. Funding long-term monitoring for an event that might not occur within a human lifetime is a challenge, requiring justification to governments, institutions, and grant agencies that demand immediate results. The paradox is clear. To capture the extraordinary, patience must be institutionalized, and human ambition must defer to cosmic timing. Amid these technical and logistical challenges lies the human story. Astronomers dedicate careers to watching a single star. Their work defined by meticulous observation, data reduction, and theoretical modeling. They balance the slow accumulation of knowledge against the chance, however small, of witnessing an event that would redefine astronomical history. The tension is palpable. The possibility of missing the death of a star that has burned for millions of years. A spectacle visible across the cosmos hovers over every observation session. It is a quiet, profound responsibility to be the eyes of humanity on a distant, unstable giant, capturing its secrets while awaiting the moment when those secrets are revealed in the brilliant, unrepeatable light of supernova. Betelgeuses, watchers embody a delicate interplay between diligence and anticipation, patience and awe. Each measurement, each spectral analysis, each carefully timed image contributes to a living archive of a star in motion. They are both chroniclers and participants, observers and dreamers, interpreting signals across the electromagnetic spectrum while contemplating the broader meaning of witnessing stellar death. In this endeavor, science transcends calculation. It becomes a form of meditation, a dialogue with time and energy on scales far beyond daily human experience. Betelgeuse, in its majestic uncertainty, compels not only observation but reflection, teaching those who study it to be attuned to the rhythms of the universe, to honor the slow unfolding of cosmic drama, and to prepare patiently for the spectacle that may come centuries hence, a supernova whose brilliance will echo across space, illuminating the intersection of human curiosity and cosmic inevitability. Of all the stars in the sky, few are observed with such vigilance and yet such humility. Betelgeuse has become not just a subject of astrophysical study, but a mirror for the nature of science itself. Instruments peer at it relentlessly, dissecting its light, its pulsations, its fleeting dimmings and brightenings. And still, the answers remain provisional, partial, uncertain. The precision of human engineering collides with the immensity of stellar time, reminding even the most advanced observers that certainty is rare and patience is everything. Each spectrograph reading is a fragment of a puzzle too vast to solve in one lifetime. The very act of watching becomes an acknowledgement of limitation, a recognition that human ambition stretches far, but not far enough to command the tempo of the cosmos. This constant surveillance has given rise to an unspoken rhythm, a heartbeat of data flowing from telescopes in Chile, Hawaii, and Spain, from spacecraft orbiting Earth, from radio dishes tuned to the whispers of stellar winds. Together they compose a symphony of vigilance, a chorus of instruments across the globe and beyond it, all pointed toward the same red star. Yet within this unity lies a haunting truth. No matter how elaborate the networks, no matter how many detectors are synchronized, the moment of collapse will arrive unannounced. Perhaps tomorrow, perhaps long after every present astronomer is gone. For all the anticipation, for all the watchfulness, the universe moves to its own cadence, unhurried and unbending, and still the watch continues, driven by something deeper than professional duty. To miss the moment would be more than a lost opportunity, it would be the silencing of a witness to history. When Betelgeuse finally erupts, its brilliance will not discriminate between cultures, nations, or generations. It will be a light seen by farmers and poets, by children in city streets and elders in mountain villages, a universal spectacle beyond borders. Astronomers know this, and it lends a weight to their task. They are not merely scientists collecting data, they are custodians of memory, the ones preparing humanity to understand what it will see. They stand as translators between the language of collapsing stars and the gaze of a species that once looked up with only myth and wonder. Yet with that duty comes a profound tension. Careers are measured in decades, grants in years, but countdown cannot be scheduled. An astronomer might devote a lifetime to its study and still pass away before its final act. Others may be young today, not yet born, who will one day bear witness to its explosion. This reality casts a shadow of melancholy across the endeavor. To spend a life waiting for an event that may not come within the span of human years is a sacrifice of sorts, a surrender to the idea that science is not about guarantees, but about presence. The watchers of Betelgeuse live with that paradox, carrying both the exhilaration of possibility and the acceptance of deferral. Yet perhaps this is what makes their vigil so deeply human. To stand watch over a star on the brink of eternity is to participate in a story larger than the self, to embrace the humility of being one note in a composition that spans generations. The data gathered today may outlast its collectors, preserved for those who will inherit both the instruments and the sky. In this sense, watching Betelgeuse is not just about prediction, but about continuity, about weaving human curiosity into the fabric of time, ensuring that, when the night finally blazes with supernova light, there will be a record, a context, a human understanding of what it means to see a star die. For as long as stories have been told beneath the stars, the figure of Orion has walked the heavens. His outline is etched into the memory of civilizations that never knew one another. A hunter frozen in time, bow poised against eternity. At his shoulder glows Betelgeuse, the red beacon that has always marked strength, vulnerability, and impermanence in equal measure. It has been painted in the desert skies of ancient Egypt, traced into the myths of Greece, whispered into the lore of Polynesia. Across continents and centuries, it has burned above human lives, unchanged to the eye, though in truth it has been living its final chapters all along. To lose such a star would not only alter the map of the heavens, but fracture something deep within the continuity of human memory. If the night sky is a mirror for the human soul, then Betelgeuse reflects its most essential truth. Everything beautiful must one day end. A star can endure for millions of years, its fires fed by nuclear furnaces of unimaginable power, and yet it too must falter, must exhaust the fuel that gives it life. In this, there is kinship between the cosmos and humanity, a shared destiny, of finitude. To watch Betelgeuse dim and pulse is to witness a reminder that even the giants of the universe bow to the same laws of impermanence that shape human breath and heartbeat. The universe is not sentimental. It creates, it sustains, it erases, and yet within that vast cycle there is a kind of poetry, a beauty that does not diminish even in the certainty of death. Philosophers and scientists alike have turned their thoughts to such mysteries. Einstein once described the universe as comprehensible yet deeply mysterious, its fabric ruled by laws that even the greatest minds could only partially glimpse. Stephen Hawking devoted his life to tracing the limits of stars, black holes, and the invisible geometries of space-time, knowing all along that his discoveries were only fragments of a larger truth. To ponder Betelgeuse is to step into the same current of thought, to accept that in its fading light lies both knowledge and mystery, both the promise of understanding and the humility of unanswered questions. The star becomes not only an object of study but a teacher, reminding those who gaze upon it of their place within the immensity of creation. One day, whether tomorrow or in 100,000 years, Orion's shoulder may flare with a brilliance rivaling the full moon. For weeks, perhaps months, the night sky will blaze with its farewell, visible even in daylight, a celestial monument to the transience of all things. Humanity will look up in awe, not as rulers of the cosmos, but as witnesses to its grandeur. Children will point, poets will write, scientists will measure, and yet all will feel the same stillness, the same silence that falls when one beholds something greater than themselves. Betelgeuse will have spoken its last word, and in its passing it will remind all who live beneath its light that they, too, are fleeting, yet capable of wonder. In that moment, the universe and humanity will share a reflection, smallness embraced, impermanence acknowledged, beauty cherished all the more because it does not last. And when the brilliance fades and Orion's shoulder is empty, the memory of its fire will linger, not only in the records of science, but in the stories whispered to future generations. For the death of a star is never just the end of a distant sun. It is a mirror held to the soul of humankind, reminding it that in the brief time allotted between birth and silence, there is light, there is meaning, and there is wonder. Through the long history of human eyes turning upward, there has been comfort in the constancy of stars. Farmers planted by them, sailors navigated oceans with them, poets drew from their glow metaphors for love and loss. Yet even in their steadfastness, stars are never fixed. Betelgeuse, for all its apparent stability across generations, is a reminder that the universe is a stage of constant becoming and undoing. Its reddened light has been traveling toward Earth for more than 6 centuries, carrying with it the story of a star already aged, already trembling on the edge of collapse. To look upon it is to see history, a relic of its state long before modern civilizations arose, and perhaps even now, unseen to us, its destiny has already been decided. The constellations are maps drawn in ink that shift while no one is watching, and Betelgeuse stands as the prime example of how fragile such maps really are. In this light, its slow dimming and flickering become less a curiosity of astronomy and more a meditation on the temporality of all things. The ancients once believed the stars to be eternal fires, divine and unchanging, guardians of fate written across the sky. Now humanity knows otherwise. Stars are born, live, and die, each carrying within it the seeds of future worlds. The iron in human blood, the calcium in human bones, the oxygen in every breath, all of it is forged in the furnaces of stars, like Betelgeuse, then released when they surrender to death. To witness its passing will not simply be to see a distant light extinguished, but to be reminded of the cosmic ancestry that lives within every heartbeat. Betelgeuse's death will not be a loss alone, it will also be a gift, scattering its essence into the interstellar winds, matter that may one day rise again as new stars, new planets, perhaps even new life. And still, there is a human sorrow in imagining the empty space it will leave. Orion, once a hunter defined by the brilliance of his shoulder, will seem incomplete. The familiar pattern that guided generations will be altered, and a silent absence will occupy the space where Betelgeuse once glowed defiantly red. Such a loss is not merely astronomical, it is cultural, emotional, existential. To gaze upward and no longer find it would be to feel the passing of something intimate, like a familiar voice suddenly gone from a crowded room. This is the subtle grief hidden within astronomy, not the grief of distance, but of recognition that even the seemingly eternal companions of the night are as vulnerable to time as humanity itself. Yet, in the face of this fragility, there is also a profound wonder that humanity, a species so brief in its existence, can recognize the fate of a star 1,000 times older than itself is an achievement of thought and imagination. The tools of science, telescopes, detectors, theories, written in equations, allow minds bound to Earth to foresee the last breath of a sun hundreds of light years away. In Betelgeuse's fading pulse, there is a reminder that knowledge is itself a kind of light, piercing the darkness of uncertainty. While the star burns, humans watch when it dies. They will understand. The relationship is fleeting, but deeply profound, a dialogue across time, a recognition that the universe speaks. And sometimes, if one is patient, it reveals its secrets in the language of fire. One night, sooner or later, that dialogue will end in an overwhelming blaze. The supernova that astronomers both anticipate and dread. When that final light comes, it will be recorded in every language, shared across every screen, remembered for as long as human beings endure. But until then, Betelgeuse remains, glowing faintly at Orion's shoulder, a cosmic hourglass counting down with grains too vast for human calendars to measure. It is a clock with no hands, marking time in silence, reminding all who look upon it that they, too, live in the interval between birth and disappearance. And perhaps, in the glow of this giant, humanity finds not despair but gratitude for the fleeting chance to exist, to see, to wonder beneath the same heavens that outlast empires and outshine the memory of all but the stars themselves. The fate of Betelgeuse compels a reflection on the fragile symmetry between permanence and impermanence. For millennia, Orion has risen with winter skies, unchanging in its bold geometry, anchoring myths across cultures from the deserts of Egypt to the frozen skies of the Arctic. To see that familiar form altered is to realize that even the deepest symbols of human imagination are drawn upon shifting sand. The hunter's shoulder may vanish, and with it, one of the anchors of collective memory. Yet perhaps this is the lesson Betelgeuse offers, that no story is truly fixed, not even those written in stars. Change is not a disruption of meaning, but the very pulse of the cosmos itself, the reminder that permanence is an illusion, and beauty often resides in the fleeting dot, in the philosophical shadow of its possible death. Betelgeuse becomes less a star and more a mirror. Its immense size and fragility reflect the paradox of human life, beings who live but an instant compared to a star's eons, yet who still wonder about their place in a universe that creates and destroys with equal indifference. The mortality of stars, so much grander than that of humans, gives perspective to personal endings. If Betelgeuse, a titan millions of times larger than Earth, must eventually collapse, then what of the brief lives that walk beneath its glow? And yet, that very collapse is the seed of future creation. Where humans see death, the universe sees transformation. Where humans grieve endings, nature prepares beginnings. Scientists like Einstein and Hawking sought to chart the underlying rhythm of this endless cycle, writing equations as if they were lines of poetry that could reveal the hidden symmetries of space and time. In their vision, stars were not mere lights, but notes in a grander cosmic symphony, each collapsing a deeper chord, each birth a new refrain. Betelgeuse is one of these notes, trembling at the edge of resolution. Whether it fades tomorrow or 10,000 years hence, it will eventually strike its final tone, and the reverberations of that music will ripple across the Milky Way. Humanity, standing in the audience of this performance, is both witness and participant, for the dust of such endings is the material of human beginnings. And so, in the quiet hours of night, when Orion rises high above the horizon and Betelgeuse burns faint and red, there is a silent understanding written across the sky. The star is both ancient and fragile, immense yet impermanent, distant yet intimately tied to human existence. One day its light will blaze in farewell, illuminating Earth in a brilliance no human eyes have ever seen. And in that moment, as the heavens erupt with fire, humanity will be reminded of its place, not at the center, not at the edge, but woven into the same tapestry of birth, death, and renewal that governs even the mightiest of stars. It will be a spectacle that humbles as much as it dazzles, a brilliant reminder that existence itself is both fragile and fleeting. The light of Betelgeuse, traveling across hundreds of light years, will arrive as a bridge between epochs, connecting the distant past of a star's birth with the present moment of human consciousness. To witness it will be to stand at the intersection of time and space, feeling the simultaneity of endings and beginnings. For while Betelgeuse collapses, scattering its material into the void, it will seed the cosmos with the elements of new stars, new planets, and perhaps life yet to come. In this act, destruction and creation are inseparable, intertwined in a rhythm that the human mind can barely grasp but can nonetheless revere. As the night sky ignites, the familiar constellations will be altered, their stories reshaped by the absence of the red giant. Orion's shoulder will no longer be the anchor it once was, and yet, in that absence, will emerge a profound presence, the awareness of impermanence, the recognition that even the greatest lights fade. Humanity, gazing upward, will be reminded of its own ephemerality, that lives, like stars, are brief flashes in a vast, indifferent universe. And yet, in that fleeting awareness, there will also be a sense of connection, a recognition that every human heartbeat, every act of observation, every story told under the night sky is part of the same cosmic continuum. Betelgeuse's death will become a meditation on scale, on time, and on the delicate interplay between mortality and eternity. In the aftermath, when the brilliant fire has faded to a ghostly remnant, the universe will continue its ceaseless cycles, indifferent yet profoundly generative, and humanity, forever changed by the vision, will carry the memory of that stellar farewell in both science and imagination. Artists, poets, and scientists alike will find new inspiration in the traces of that red giant's passing, embedding its story into culture, theory, and memory. The death of Betelgeuse will not signify an end, but a transformation, a testament to the enduring dialogue between the cosmos and those who dare to look up and reflect. It will remind us that, though small and transient, humanity is capable of bearing witness to the sublime, of measuring, imagining, and revering the majesty of a universe that exists on scales both terrifying and beautiful. And so, even in absence, Betelgeuse will persist in light, in dust, in the shared understanding of a species that dared to watch and wonder. Its story will echo across generations, a luminous thread woven into the fabric of human consciousness, forever linking the ephemeral life of a star to the enduring curiosity of those who dwell beneath its sky. In its death, there is life; in its fading, there is illumination; and in its silence, a reminder that awe, like the cosmos itself, is boundless.